morning, students. Today we'll do the structure of methane. In methane, carbon atom undergo sp3 hybridization and how the molecule will form by hybridization. So that I'll show you. So yesterday we have got when carbon undergo sp3 hybridization, it will produce 4 sp3 hybrid orbitals, and that 4 sp3 hybrid orbitals, they are tetrahedrally arranged like this. This is a 3D structure. One lobe is larger, another lobe is smaller one. So these are the 4 sp3 hybrid orbital of carbon. Carbon produce this hybrid orbital, and every hybrid orbital contain one electron, and the bond angle between two orbital is your 109.5 degree. When the molecule adopt tetrahedral shape, then bond angle always you will get 109.5 degree. Now when this carbon combine with 4 hydrogen, as you know, hydrogen contain 1s orbital and it contain 1 electron, and s orbital is spherical in shape. So one s orbital overlap with this sp3 like this. This is 1s orbital of one hydrogen atom. sp3 contain 1 electron, hydrogen contain 1 electron, so here you will get 2 electron. So a bond will form, and that bond will be sigma bond because head-on overlap. Similarly, another hydrogen overlap with this sp3. This is hydrogen 1s orbital. It overlaps with sp3 hybrid orbital of carbon. It produces another sigma bond. Similarly, this 1s or this sp3 orbital overlap with another hydrogen 1s to produce another carbon hydrogen sigma bond, and the fourth hydrogen overlap with this one, it produces another sigma bond. Actually bonds are produced like this way. So in the formation of methane, this side one carbon hydrogen single bond sigma bond, this side one carbon hydrogen sigma bond, this side one carbon hydrogen sigma bond, and this side one carbon hydrogen sigma bond. Like this. Here I am using dotted line and dash line because yesterday I have told you it's a 3D structure. This orbital is below the plane and this orbital is present above the plane. So this dash line represent the bond is above the plane, and dotted line represent it is below the plane, and the bond angle in between the bonds, in between all the bonds, you will get exactly 109.5 degree. And since the carbon atom in methane undergo sp3 hybridization, that is why its structure is tetrahedral. So if someone asks you why methane will adopt tetrahedral shape, the answer will be in methane the carbon atom undergo sp3 hybridization, and that is why its structure is tetrahedral, and the bond angle will be 109.5 degree. You know, alkane like methane, ethane, propane, butane, all alkane, since they contain single bond only, alkane contain only single bond, all alkane, in all alkane the carbon atom undergo sp3 hybridization, whether it is ethane, methane, propane, butane. In every alkane carbon undergo sp3 hybridization like this. So this is the structure of methane. Methane produce 4 bonds like this way by overlapping between sp3 orbital and 1s orbital of hydrogen atom. So this is sp3 hybridization. Similarly, if you want to draw the structure of ethane, ethane you know its formula is C2H6. This is ethane. If you want to draw the structure of ethane, since ethane contain 2 carbon and both the carbon will undergo sp3 hybridization. So this is one carbon, it produces 4 sp3 like this. This is one sp3. So you have to maintain the tetrahedral shape, and when you draw the tetrahedral shape like this, This is the tetrahedral shape. Bond angle should be 109.5 degree, and this is for one carbon. These are 4 sp3 of one carbon. Similarly, another carbon undergo sp3 hybridization. This is another carbon. The sp3 hybrid orbital of this carbon overlap with another sp3 of this carbon. Since both contain 1 electron, head-on overlap, you will get a sigma bond between carbon and carbon. And another 3 sp3 for this carbon. One should be present like this. One is below the plane, one is above the plane like this. These are 4 sp3 of another carbon. Now there are 6 hydrogen. 3 hydrogen overlap with this 3 sp3 and another 3 hydrogen overlap with this 3 sp3. So one hydrogen 1s orbital of one hydrogen overlap with this produces sigma bond. Another hydrogen overlap with this, it produces another sigma bond. This is another overlap to produce sigma bond. All are sigma bond. So 3 hydrogen combine with this carbon and another 3 hydrogen combine with this carbon. This is hydrogen 1s, sigma bond. Hydrogen 1s overlap with sp3 to produce sigma. Hydrogen 1s overlap with sp3 to produce sigma. Like this way the ethane is formed. So if you want to draw the structure of ethane, first time carbon produces sigma bond, and this sigma bond is produced by overlapping between sp3 and this side one carbon hydrogen bond. This is below the plane, so you write dotted line. This is above the plane, you write dash line. Similarly, this carbon, this side one carbon hydrogen sigma bond. This is below the plane, dotted line, and this is above the plane. You put dash line. And this is the structure of C2H6 ethane. And if someone asks you what is the shape of ethane, here also the shape of ethane is tetrahedral due to sp3 hybridization, and the bond angle in all bond angle you will get 109.5 degree. So this is about sp3 hybridization. All alkane like propane, butane, they also undergo this type of hybridization, and they will adopt the tetrahedral shape with bond angle 109.5 degree. So you try to draw the structure of propane, butane, pentane, any alkane you can draw the orbital diagram by applying hybridization like this way. Thank you.